Hello and welcome. Well, if you've been following me for any length of time, you've probably seen me use my square column drill press. I've used the heck out of it and I really like it. But I built a slide table, or a XY table, mill table if you want to call it that. And I've used it a lot and it's been extremely useful, but it's got some problems that I can't seem to resolve. So I bought a commercial one, and I'm going to do a review on that today. Let me show you what's wrong with this slide table. Here's the problem I have with this. It's got about 15 thousandths backlash, which in itself is not a big deal. But if I'm drilling something round and I'm trying to hit the center of it, when the drill tries to walk around on the top of that curved surface, the table moves one way or the other. And there's no way to lock it. It's be difficult to get rid of the backlash. Definitely difficult to get rid of all of it. But it's really difficult to figure out how to lock this table. So I'm going to do the typical unboxing of this Vevor XY table, or mill table. And well, let's get started on that. Okay, just to be 100% up front, Vevor gave me a discount on this table when I told them I was going to do a review on it. But I told them that this would be a 100% honest review, and they were willing to take that chance. So, but they did ask me to mention that they got a 30-day free return, 12-month guarantee, 24-hour shipping after you order, and usually you'll get it in 5 days and it's free shipping. So with that said, let's unbox this thing and see what we got. It's fairly heavy. It's about 70 pounds. For the seems to be in good shape. Get this thing out of here. One thing that I told them I would probably do on this is put new dials on it and new lead screws. I don't know how big a job that's going to be, but we'll find out. Seems to be made pretty good. Plenty heavy. Of course, if you're in a country where you don't use that crazy inch system, you'll probably want to leave the lead screws the same. The castings are not real smooth, but for 144, I think it was, can't expect it to be perfect. To me, that's a pretty good price. Anyway, I thought it came with some kind of dial. One thing that worried me, and I can deal with it, but it's got to hang off the edge of the drill press table. To be able to put this knob on. Oh, there's the dials. Kind of faint. That's 1, 2, 3. I wonder what that is. 4. We'll measure that and find out. Okay, I've got my scale on my caliper set at metric. See what we got. 4 millimeters. 8 millimeter. 12. 16. So that one turn is 4 millimeters. I assume the other one's the same way. Well, it's got a little play in the handles. It really doesn't hurt anything. I don't like it, but I think it's going to work out all right. So next step is to take it apart and let's see how it's made inside and look at getting some lead screws ordered for this. Okay. I like the way this goes together. It's got thrust bearings in there. I can take out any, hopefully I can make those thrust bearings work with my new lead screw. I don't know what I got in the way of nuts on the bottom of this. That may be an issue. Interesting. I'll probably want to clean those up and smooth them up. Well, that's not too bad. I think I can make one of those. I think it was actually hitting on these screws right here, and when I pushed, yeah, if I'd taken that off, it would have come off. Yeah, by pushing it that way, it allowed me to lift it up and clear the end of those screws. Well, not a tremendous amount of attention to details, but I'm impressed. Took some of the sharp edges off with some emery cloth. Not necessary, but adds a nice touch. Got it all apart, might as well. These gibs definitely need to be cleaned up. That'll make everything move smoothly. Got an oil port right there. This is what I was wondering about. Very slight ledge right there. Anyway, I'll have to address that. I need to order some lead screws now. .17.5 millimeter, which is 0.689, probably going to have to be 3/4. 16 and 12 should be enough, 3/4 inch, 3/4 by 10. Okay, I pretty much got it apart here. And I was going to put Acme thread in there. I was going to put a 10 thread per inch, 3/4 inch Acme in there. And I started pricing Acme thread, and it's really outrageous. Then I got to thinking, this is an XY table. They call it a mill table, but you're not really going to be doing any milling with it. It's going to be for positioning drill holes. So even under load, a 3/4 inch standard thread would hold up really well. But for what this is going to be used for, really this will work great. And it's quite a bit cheaper. I mean, that piece right there was $12, I think, and that was $6, something like that. A little cheaper than that, I think. Anyway, then I got to looking at these blocks right here in an Acme thread, and that's more money. And then if I made the blocks and bought the taps, that's more money. Ended up being like 150 bucks. So what I decided to do is go with this thread. And then I got to figuring it up, and the outside of this Acme thread, the original Acme thread, is smaller than the drill size for 3/4 inch standard thread. So what we're going to do, we're going to chuck that in the four-jaw and bore that out to the drill size for a 3/4 inch tap and tap a new hole in there, hopefully. But what I got to do is I got to build a shaft that goes into there so that, well, let me show you. I'm going to cut this shaft down here so that slips over. And then I'm going to flip this shaft around and put a center on the end, and that will help me center it in my four-jaw. I'll have the shaft in the nut, and I'll put the four-jaw in the nut, and I'll have the other end in my tailstock, and it'll help me center it. So that's what I'm going to do now. I'm going to turn that down to that diameter. Okay, as near as I can tell, I need to go about 54 thousandths. I'll go about 50 and then double check it. I think I'll go a little faster than that. Well, it's not exactly bored straight through there, is it? I don't know if I need to try to use that or not. Okay, I turned the bar down to fit the inside of the threads on the original nut for the lead screw. And as you can see, it's very, very crooked. And as long as it'll mount straight, that probably wouldn't hurt anything. But these screws right here in the mounting holes were to a limit. I'm a little bit afraid when I get the new lead screw in there, I won't be able to stop it from binding. So I'm going to build a new nut out of that. It's just barely big enough. Screw width right there is a little bit, it's going to be close, but it'll be all right. But to do that, I wanted to make sure everything was lined up. And this table, near as I can tell, is very accurate. But I made a sleeve that fits in this bore right here, and my transfer punch fits in there. Now I can stick this in there and transfer my hole position. I'm just going to eyeball it this way. But this upper casting, which this nut mounts to, is about 10 thousandths above this surface here. So I'm just going to guesstimate there and hold everything, and then tap it. And there's my hole position. Now I'm drilling a 3/4 inch hole and threading it through there, so I need to have enough steel there to go 3/8 to this side of that hole. So that's going to work good. So that's the next step, is to drill this. Okay, the best way to drill a straight hole through that block is in my lathe in a 4-jaw. So what I need to do is center that punch mark I made with the tailstock center. Really what a person could do is make himself a wiggler. Goes in the tailstock, and then you could just put it in that little recess and turn the lathe on and see if it wiggles. Let's go that way. Okay, I've got the tap size drilled all the way through, but I don't need, what is it, about 1.5 inches worth of threads. All I really need is maybe 5/8 to 3/4 inch thread depth. So what I got here is a drill that's 1/32 over 3/4 inch. So I'm going to drill 1.25 inches into it. And it's really not critical. You only need about 1/2 inch threads, really. So 1.25 inches, so that is 10, 12.5 turns. 12.5 turns on my tailstock. Two, 4. Okay, this is going to take a fair amount of torque to thread this 3/4 inch. So I'm going to get my tool post out of the way. Lubricate the heck out of this tap. And the tap has a center in the back of it. I'm going to use it to keep it aligned and put pressure in it, especially to get it started. Yeah, that's very nice fitting threads. Got a little bit of play, which is good. Otherwise things become extremely critical. That clearance right there goes into about right there, so I got about 5/8 thread. I hope that's not too much. With less threads, you got more forgiveness as far as misalignments go. But of course more threads is better for wear and probably reduces the backlash a little bit. Okay, here's what we got. I'm replacing the metric lead screw with a 10 threads per inch standard thread 3/4 inch. This is the cheapest I could find, and it's actually really good quality. I replaced these nuts, made new ones. I probably could have bored them out and rethreaded them, but you can see it's getting pretty thin there, and it's made out of cast iron. Plus, the hole in this one goes through there crooked. I mean, quite a ways off, and I didn't want to fool around with trying to clamp that and get the hole straight. I remade this one, and you'll notice I made it a lot narrower. And it's just not necessary for it to be that wide. It might be with cast, because cast is a little weaker, but with steel, it just increases the friction and makes it critical for alignment this way. This one's a little bit more forgiving for movement this way, or alignment. So I remade both nuts. There's the other nut. And you'll notice on this one, I don't know if you can see that or not, I drilled a clearance hole about that far through. So there's probably 5/8 thread, which is about what that is. That's 3/4. But that's all that's necessary. Anyway, right here I've made a mock-up of the direction I want to go with this lead screw. I just took a piece of 3/4 inch shaft instead of taking a chance on ruining this, and designed a I ordered new. This is something kind of weird. Right here, this is original, this is original. That was the original fit. Well, this hole here is, if I remember right, 16 millimeter. And that's like 15. So I turned that down so there was a good fit in there. And then, but I had to order new thrust bearings, because the original thrust bearings fit that shaft. Anyway, that goes through there like that. Thrust bearings on both sides. And this sleeve right here, it's just a smooth sleeve inside and out. Fits over that. And then there's 2 lock collars that will lock it down to this flat area. And then when I make the new lead screw, I'll make this a lot longer. And this is half 13. That will adjust the clearance on these thrust bearings. Then I'll put this over that, and the shaft will stick out here, and I'll put another nut right there, and then I'll lock them down on the handle. It was keyed. I don't think keying will be necessary, but if it is, I'll cut a key in there. I was trying to avoid any kind of mill work and make this doable with just a lathe, and I really believe you could do that. This right here, I used a mill to notch that out. I could have taken a bandsaw and cut that out, no problem. Machine the whole thing and then cut out those cutouts. Probably would have been a better idea than trying to hog all that off with a mill anyway. So the next step is to build the real lead screw with a longer thread here where I can put my handle on it. And I've got plenty of length. So that's what we're going to do now. Forgot to mention, I also cut this dial off. It had a recessed area in there. I cut that flange off. That has some increments on it in metric. They're hard to read. But this right here will be a sleeve and a dial that fits over this hub. And I'm going to put a nylon tip set screw in there so that you can set the tension on the set screw and re-zero your dial. That'll be a dial. And then this will go on top of that. Anyway, this is the next step right here. Okay, these thrust bearings are .344. It's 886, 688. So, what I want to do, actually, no, I couldn't do that. I want to measure, this is a 1-inch slug. I want to measure how long I want that turn place on my shaft there. So, I can't measure down in that hole, so I put the 1-inch slug in there. And it's 2.13. 2.132. And then I want to add those together and subtract 1 inch. That's 1 inch for that. So minus 1.0 is 1.820. So that's what this length right there needs to be, is 1.820. Okay. First thing I want to do is create a place for my center, drill a hole for my center. And I need about 5 inches of stick out. 5 plus a ½ inch. ½ inch just so I don't have to cut right up to my chuck. You don't have to use a collet, but a collet's better. A little easier on the threads maybe. Okay, we're going to test fit this. I could take a little shoulder off of there, and I may do that if necessary, but I'm going to cut just a little bit off that shoulder right there. Needs to be really about halfway through that washer right there. Get an idea what that needs again. Just going to eyeball it. Okay, I made this thing right here 7/8 of an inch. You could make it 1 inch. You could make it 1.25 inches. However wide you want your dials. These are 3/4 inch dials, or 3/4 inch wide, and that's just perfect to slip over that. It's not super critical, but you need that surface there about the same width as your dial is going to be. So, based on that, I want to scribe a line right there. I'd turn it on and do it. Okay, I got to cut a place to end my threads, and my scribe line is right there. I think that'll be deep enough right there. Yeah, my tailstock wasn't locked down. Okay, now we're going to thread. Okay, I was just barely touching. I'll go in about 10 thousandths. Make my first scratch pass. I like it. Now I can turn the threads down to make this fit. This is metric. And that's what I did on the test piece, and that's what I'm going to do on this. It's a very slight amount, and the strength of your threads is not in the tips of the threads, so it's not going to hurt anything. I like it. That shaft is basically done. I may have to cut this lead screw off. I don't remember how it compared to the old one. It may run into this casting here. Ah. Yeah, I don't need to cut off much of it. About 1/8 of an inch. Let me cut that off. Okay, there's our dial bushing, if you want to call it that. The dial will turn on that, and I'll use that to determine the shaft size when I make the lead screw for the upper part of the table. Okay, rather than do the math, I'm going to do this mechanically. Okay, right to there needs to be turned down to 1/2 inch, so that'll go up against it. Oh yeah, that'll work good. Perfect. Now we need to know where to stop our threads. That'll work. Well, there it is. Works really well. Considerably tighter than what it was. I'll cut these off right here when I make the dials. Those dials will mount right there. Also, these handles leave a lot to be desired. I don't know. They'll work, but they're kind of, threads bottom out and then they're loose. I'm going to make, I got these bolts here. I turned the head down a little bit more. It fits down in that hole like that. Then I'm going to turn that down and thread it to fit in there. It's metric thread, M6 I think. I'll turn that down and cut some metric threads on there with my South Bend lathe. It's roughly equivalent to 24 threads per inch. Be close enough. Okay, I've had this XY table, mill table, whatever you want to call it, completely assembled, and I'm really pleased with the way it came out. But this is a review, so I'm going to go into the original mill table and each component and pluses and minuses. The hand wheels, basically good. These handles are real loose, didn't fit very good. But that's just, they're totally functional, so I gave them a rating of 6. The dials, I turned off of here. They were extended out about that far. I'm going to give them a 4. They were 4 millimeters per revolution and very hard to read. 4 millimeters is kind of weird. I don't know why they went with 4. 5 or 10 would have been pretty nice, but 4 is really weird. The lead screws, I'm giving them an 8. The quality on them is substantial. They're Acme thread. The lead screw nuts, they're cast iron, which is fine. This one was pretty good. This one here, they drilled the hole in crooked. But there was enough adjustment in those screw holes to where it was turned straight and it worked fine. The lead screw brackets, these were not very well made. The holes were not drilled to the same spacing as the table, and they were kind of forced in there. The depth is a little off, and I believe the positioning is a little bit off in relation to the lead screw. But this is what bothered me the most. And that's actually undersized on the lead screw, I would say. This is 16 millimeter, I believe, but it's true to size. So I'm going to give these lead screw brackets a 3. Something else on these lead screws, these nuts were drilled crooked. It looks fairly straight. One of them was really crooked. There you go. But it works. So anyway, move on to the next one. The main castings. The main castings were very good quality. They were a little bit rough. I took some emery cloth to the edges, but they're very good quality. These holes here for the upper lead screw nut seem to be off center a little bit, but that may have been the bracket being off center. So I don't know. I drilled the holes oversized in these brackets and put washers and a screw on it so I could adjust that. Anyway, let's put this thing together and I'll go through some of the changes I made as I go. Okay, there's the nut I made. When you make this, if you make this, these holes kind of intersect with this. You can see it right there. That's not a problem. They don't really have to be that deep, but you got to go deep enough so that you get threads all the way to the bottom. If you intersect with the threads there, just run the tap back through there and clean up the threads. That goes right there. Okay, when you put this together, make sure the table is reasonably snug. If you got these loose right here, your table can move this way and you want it to be fairly close to where it's going to run all the time. On the lead screw, it's threaded on both ends. I mean on one end. This area right here is only threaded and this is just unthreaded. That's just a clearance right there. Put that toward the handle. That goes right there. And you can line the holes up right here. The reason I said that clearance area needed to be toward you was because when this nut gets close to the handle, if there's any misalignment, it gets really critical and it'll try to bind up. Matter of fact, if you have problems lining this up right here, you can oversize the holes in these brackets. That's what I did on this one. This one here I didn't have to. You can oversize them and put washers under them, do it like that. Just snug those down. Snug these down. And see if the table moves to full. It's getting a little bit tight right there. That's either the lead screw being slightly out of alignment, it's still a little tight, or it's these screws being a little out of alignment. Keeping everything lined up on these is kind of tricky. That's pretty good right there. So we can go ahead and tighten everything. Okay, now we got to attach the lead screw nut for the top table. This lead screw, you can see I counterbored it a little bit right there. I could have done the same on the other side. Really, I could have made that out of 1/2 inch, just like that. And it might have been better because 1/2 inch is more than enough threads. I was just a little bit worried about support this way, but I don't think it'd be an issue. So when you make this thing, here's what I would suggest. Position that hole right there, and it's on the plans where you need to put that hole. Put it in a 4-jaw chuck, drill it, and tap it. Then take on a bandsaw and make that cut and that cut, that cut and that cut. And you can drill it before drill these and then cut it. And you don't have to have a mill. You can just file it a little bit. It doesn't have to be super smooth. But this position this way, and especially this way, is very critical. I made this in my drill press, and I had that very slightly cocked this way, and I had to mill the bottom of it at an angle to make that work. So drill that in your 4-jaw chuck. Or a mill. So I've got some scribe lines here because I know where it worked and where it worked well. So I really struggled with getting this alignment until I realized I needed to oversize these holes, and after I did that, it allowed this bearing block to float, and it worked way better. You may need to get some new screws. I ground the top of that one because my lead screw hit it when I first put it in, and after I got everything aligned, there was clearance there. But like on this here, after I oversized those holes, I had to put longer screws in there so that, because it's not going down into that counter bore. So anyway, next step is to put the table on. I don't know if it matters which way this goes. That keeps it from sliding. And apparently I had it this way. Yeah. For this setup, just snug these real good and then back it off. Back it off a little bit because you need the table to move. Move freely. Now we need to put this lead screw together. Thrust bearing, bearing block, thrust bearing, dial hub. Those little set screws go toward that flange. See, it's got a keyway there. I may need to key that. It'll work without keying it, but that may be something you'll want to do. Yeah. I probably need to run a tap down in the table, make those holes a little deeper. The holes are deep enough, it's just not threaded very deep. I'll do that. That's the limit right there. That's actually not binding up at all. When I originally put this together, that nut in there, I left it just a little bit loose, and it kind of found its own center, and then I just carefully took the table off, and actually I think I just took these off and slid the table where I could get to those bolts in there that hold the nut, and tighten them down. See, I got some slop there, so we can tighten these now. See, right now, let's see how much backlash I have. That's how much backlash. That's not much. And I didn't have any trouble tightening that, so I like it. I don't think it's necessary to key that that 1/2-inch thread there on the handle. Well, that about wraps it up. Part 2 will be putting these dials on, and that'll really complete the build and make it very useful. This hub right there I'll lock to the shaft and bore that out to fit that hub, and the dials will be, the markings will be on that. And I'll put a nylon tip set screw in there where I can hold the handle and slip the dial back to 0. That way if I need to move it 70 thousandths, I can slip it back to 0 and then just go right to 70. Anyway, that about wraps it up. Be sure and ring the bell and hit subscribe. Thanks for joining me, and stay tuned for part 2.